Hi, future nurses, Professor Van Greger here. And in this video, we're going to be talking about how to start your dimensional analysis problems. I have three very simple steps in how to start dimensional analysis problems. Let's go ahead and write them out, and we'll explain what they are using different problems. So the first one is if there is a weight, you are always going to start with the weight. It is a very simple step. If you have a kilograms or pounds in your problems, that's what you're going to start with. The second one is a single unit order. And I'll go ahead and explain that in our second example in today's video. The third one is going to be matching the label with the answer. And we'll do that example in problem number 3 in this video. So go ahead and make note, write these down, and we'll go ahead and explain them using examples. So for the first problem, we're going to do a weight-based problem because the first golden rule to start problems is if there's a weight, start with weight. So for the first one, we have an order. Our order is 10 milligrams per kilogram. Our weight of our patient is 15 pounds. And so we're going to be trying to find how many milligrams we're going to give this patient. And for this problem, I want to round to the nearest tenth. So we always want to keep that in mind, and we'll do that at the very end. So for our golden rules, our number one rule is if there is a weight, we're going to start with the weight. We always also want to make sure we're putting our answer labels in. So for our answer, we know we're looking for milligrams. Now to start our problem, golden rule number 1, remember, weight. If there's a weight, we start with it. And we have a weight right here. So we're going to go ahead and start with our 15 pounds. And then we're going to go ahead and get rid of the labels that don't match. We're going to go back to that first video. Remember, it's all about labels. So if we have pounds on the left, milligrams on the right, we need to get rid of pounds. We have pounds, or we don't have pounds in our given information. So we're going to use the relative. Remember, the relative is something we have a conversion factor for. This is going to be 1 kilogram is equal to 2.2 pounds. So we're going to go ahead and put our 2.2 pounds on the bottom, 1 kilogram on top. Our pounds cancel out. And now we have kilograms on the left, but we want milligrams. And so now we can use our given information. So we can go ahead, we want kilograms to go away. So our kilogram needs to go on the bottom from our order, 10 milligrams on top. Now our kilograms cancel, and we're left with milligrams as our label on the left side of the equation and milligrams on the right, which means we're done setting up this problem. So we can go ahead and do the arithmetic now. So for the arithmetic, we're going to multiply everything on the top. So 15 times 1 times 10 is 150. On the bottom, we have 2.2, which is going to net us 68.18. But this answer, remember, said round to the nearest tenth. So we're going to go ahead and underline the 10th position. Look to its neighbor. It is 5 or higher, which means our final answer is going to be 68.2 milligrams. And so in this problem, we're going to give 68.2 milligrams to our patient. So now let's check out our golden rule number 2. So golden rule number 2, remember, is using a single unit order. So what does this actually mean? A single unit order means in your order, you have one label. So for our second example, we have an order of 15 milligrams. Available is 20 milligrams per 5 mLs. And you can see there's no weight, so we can't use the first golden rule, but there is an order with one label. So when you have this scenario, we 1000% are always going to start with that order. We're looking for milliliters in this problem, so we want to make sure we have our equal sign, and we're going to start with our order. So we have 15 milligrams. We've used it, cross it out. We now want to get rid of milligrams, and we have milligrams in our available information, so we can use it. 20 milligrams is going to go on the bottom, so the milligrams cross cancel, and 5 mLs on top. And now our milligrams go away, and we're left with matching labels. We have milliliters on the left, milliliters on the right. Now all that's left is to do our arithmetic. So 15 times 5 is going to be 15 times 5 divided by 20, right? 15 times 5 divided by 20 is going to equal 3.75. We want to round this to the nearest tenth. So we look at our neighbor. So it's going to be 3.8 milliliters as our final answer. Now let's go ahead and take a look at our third problem and our third golden rule. And remember, our first golden rule, if there's a weight, we always start with weight. Second, a single unit order. So if your order only has one label in it, you're going to start with that. But what happens when neither one of those things are true? We're going to go ahead and use our third golden rule. That's going to be match the answer label with our given. Okay, and let me go ahead and explain a little bit and show you, and it'll make a little bit more sense. So our order is 1 liter. We're going to give 1 liter of fluids over 10 hours. Our drop factor for this tubing, right, how big that tubing is going to be 20 drops per ml. And the question that's being asked is we want to know the drop rate, which is found in drops per minute. So for this answer, we want drops per minute. And if we go through our golden rules, 1, weight. There's no weight in this problem. 2, a single unit order. Well, this order has 2 different labels, so we wouldn't know what to put in the numerator or what to put in the denominator if we just pick to start with the order. That's where the third rule comes in. You're going to match your answer labels. So in our answer, we have drops and we have minute. So we're going to look to our given information and we're going to see if we have any drops or minutes there. And I see drops right here. So what we're going to do is we're going to place that label in the correct position according to the answer. So in the answer, we want drops in the numerator. So we're going to go ahead and just use this drop factor and put the drops in the numerator. So now our numerator is complete. We have the same label on the left side of our equation in the numerator as we do on the right side of the equation in the numerator. So now the label we need to get rid of is milliliters. So we're going to look to our given information and see if we have any milliliters. And we don't, but we do have a relative. Liters and milliliters, we know a conversion factor for. So in this instance, milliliters needs to go on top. So 1,000 milliliters is equal to 1 liter. So now our milliliters cross cancel. So we're going to go back to the same question. Do our labels match? Well, we have drops per liter on the bottom, and we have drops per on the left, and we have drops per minute on the right. So they still don't match. We got to get rid of liter. But we have liter in our given information. So we can go ahead and put our liter on top, our 10 hours on the bottom. We've used this, get rid of it. And now our liters cancel. And we're still not done with this problem because we have hours in the denominator on the left side and minute on the right side. But we know a conversion factor for that as well, right? We know that 1 hour is equal to 60 minutes. So we can now cancel out our hours. And if we take a look at our labels on the left, we have drops per minute, and our answer labels is drops per minute. So we are now equal labels on the left and the right of the equation. So now all that's left is the arithmetic. So when we do our arithmetic, we're going to go ahead and multiply everything on the top. So 20 times 1,000 times 1, which we don't really need to do, is going to give us, I'm going to go ahead and make some room here, is going to give us 20,000 in the numerator. And then on the bottom, 10 times 60 is equal to 600, which is going to give us an answer of 33.33. And in this answer, we're going to round to the nearest whole number. So we're going to underline our whole number place, look to its neighbor, and it's below 5. So our final answer for this problem is going to be 33 drops per minute. So I've shown you examples of all three different types of problems you're going to run into and how to start them. Just remember, we're always going to start with the weight if there's a weight, right? 1 is going to be weight. 2 is a single unit order. And 3 is going to be match, label, to answer. If you can just remember those 3 simple steps, it will help. It will make it so that you can start any problem that you're going to see in your MedMath curriculum all the way through nursing school in practice. You'll be able to start every single problem. And once you have the starting point and your ending point, every single problem is done exactly the same way. Please make sure you subscribe. I'm going to be uploading videos a lot more regularly, and then you can be able to see example problems as well as some theory-based lecture videos.